All right. So, experimental and theoretical probability is what's up for today. So, let's say you find an old clock in your attic. The hour hand of the clock is broken off. Between 12 and 2, how many positions are possible for the hour hand? For a 12-hour period, how many positions are possible for the hour hand? So what is the probability the clock stops sometime between 12 and 2? All right. So how many numbers are there in the clock? 12. Oop. There's 12 numbers on the clock. How many numbers does it take to go from 12 to 2? 2 numbers. So there's a 2 out of 12 or 1 out of 6 chance that it stops somewhere in between the 12 and the 2. Okay? Now, this is an outcome. Okay? An outcome is a possible result of a situation or experiment. An event is figuring out the probability. Okay? It could be one outcome or it could be a bunch of outcomes, as we'll see when we're rolling a die. Okay? And then the sample space is all of the outcomes listed out. And again, we'll see one in a little bit. Okay, probability. Probability is a numerical value between 0 and 1. It can't be bigger than 1, can't be less than 0. That measures the likelihood of an event. And you take the number of favorable outcomes over the total number of outcomes. If we would be talking about odds, it would be favorable to unfavorable. So if I have 2 to 1 odds that it's going to be cold tomorrow, okay, then I've got 2 out of 3 chances that it's going to be cold, okay? So my probability would be 2 out of 3. My odds are 2 to 1. They're two separate things, okay? All right. So if things are equally likely to occur or not occur, you have a 50% chance of it happening. So your probability is 50% or 0.5. If it's going to happen, okay, it's 100%. It's not going to happen, it's 0%. Okay, experimental probability is doing something like running an experiment to see how many times something happens over the total number of times it's done. So, a quality control inspector samples 500 LCD monitors and finds defects in 3 of them. What is the experimental probability of having a defect? Well, there were 3 defective out of the 500, so if you divide them, you get 0.6%. The decimal 0.006 is 0.6%. Now, on the worksheet, we have an answer of like 45%. And some people put that down as 0.45%. Well, there's a huge difference between 0.45% and 45%. And if you put down a decimal point where there's not supposed to be one, you'll get it counted wrong. Okay? So, 0.6% is really small, hardly any. Okay? Because it's the decimal 0.006. So when you change a decimal into percent, remember you have to move the decimal point 2 places. So let's say the company manufactures 15,240 monitors in a month. How many do they expect to be defective? Well, you take your decimal, your probability of being defective, 0.006, which you found up there, times the 15,240, and about 91 monitors will be defective. Okay? All right. A park has 538 trees. You choose 40 at random and determine 25 are maple trees. What's the probability that when you look at a tree, it's going to be a maple tree? How would I write that fraction? How would I write that fraction involving the 25 trees out of the 40 trees I witnessed? How would I write that, Trevor? we see 25 are maple out of the 40 trees I saw. That's all we have to do, 25 over 40. Let's change that into a decimal. So what decimal is that, Brooklyn? It's 0.625, which is 62.5%. So 62.5% of them are maple trees. Now, if the park has 538 trees, how many do you think are going to be maple trees, Christina? If the park has 538 trees and 62.5% of them are maple trees, how many maple trees do you think are going to be in the park? More than half. But we want a number on these trees. We want to know how many there would be. Mr. Downs? How many do you think there are? What would you do with your numbers? If you have 62.5% of them are maple trees, and then you have 538 trees, what would you do with those two numbers? Divide? I don't think I would divide. What else could you do, Lilith? Multiply. If you multiply those, Lilith, what did you get? How many?
Do I take 0.65 or 0.65?
Yeah. Because if we put 62.5, you'd get 33,000, right? Can you, if there's only 538 trees in the park, could you have 33,000 maple trees? No. How about 336 maple trees? Exactly. 336 maple trees. About. Because we don't know for sure. Okay? That's about how many we're going to have. All right. So that's experimental probability. You have a situation, you figure out the percent, and then you multiply it by another number. Okay? Because you're not going to count every tree. You're just going to take a random sample, figure out the percentage that are maple, and then multiply it by all the trees. Okay. Theoretical probability is based on mathematical reasoning. Okay? This is the card sharks in Vegas. They use theoretical probability to figure out if they can win or not at a game. Okay? A standard number cube, also known as a die. What's a die? What's the plural of die? Dice. Okay? You're playing Yahtzee. Anybody ever play Yahtzee anymore in here? All right, we got a couple of Yahtzee people. Okay? That's from back in the olden days. But you roll a die. You have 6 different numbers on there. 1, 2, 3, 4, 5, 6. So what's the probability I roll a die and I get a 2? 1 out of 6, because there's 6 sides. 1 out of 6. What's the probability I get a 5? 1 out of 6. It doesn't matter. Okay? If you roll one die, the probability of getting any of the 6 numbers is 1 out of 6. Okay? So, if I roll 2 die, okay? If I roll 2 at a time, I could get a 1 and a 1, or I could get a 1 and a 2, or I could get a 2 and a 1, and so on. How many different possibilities do I have here? How many different possibilities do I have when I roll 2 die? 36, 6 times 6. So there's 36 different possibilities, okay? This is called a sample space. This is called a sample space, where it shows all of the different possibilities for answers. All right. So they say, what's the probability of rolling a 2 die that add up to 7? Well, 6 and 1 add up to 7. 5 and 2, 4 and 3, 3 and 4, 2 and 5, 1 and 6. There's 1, 2, 3, 4, 5, 6 of the 36 add up to 7. So you got a 1 out of 6 chance when you're rolling die of getting a 7. What's the probability of rolling a 9? Which numbers add up to 9? What do numbers on that chart add up to 9, Jordan Torres? 5 and 4. So you got a 4 and 5. Any others? 6 and 3, 3 and 6. So there are 4 out of the 36 or a 1 in 9 chance. What's the probability of rolling a 2? Two numbers that add up to 2. How many of those add up to 2 on that chart? Just 1. You got a 1 out of 36 chance. What's the probability of rolling a 13, Sammy Troxel? Which one of those adds up to 13? None of them. So what's your probability going to be? A big fat 0. Okay? You have no chance of rolling 2 die that'll add up to 13. So that's a 0% chance, 0 probability of that. Okay? All right. The complement of an event consists of all the possible outcomes in the sample space that are not part of the event. So let's say today there's a 70% chance of rain today. If there's a 70% chance of rain today, what's the percent chance that it won't rain today? 30%. Okay, 30%. So the probability of something happening is 1% or 1 fraction. The probability won't it happen, you take 1 minus that. Okay? So a jar contains 10 red marbles, 8 green marbles, 5 blue marbles, and 6 white marbles. There's 29 total marbles in there. What's the probability the marble selected is not green? Well, you figure out how many are green and subtract it from 1. So it's 21 out of 29. So what's the probability the marble is not red? What's the probability that it's not red? Well, how many red ones are there? 10. So 1 minus 10 over 29. Well, 1 is 29 over 29. So what's 29 minus 10? 19 out of 29. There's a 19 out of 29 chance that the marble is not red. Not red. All right. Let me jump from there to there. Okay. What's the probability that if you spin the spinner, you're going to land on a red space? Probability that you're going to land on a red space there, Levi? How many red spaces do you see in this first picture? 3. How many triangles are there? 8. So you got a 3 out of 8 for landing on a red. What's the probability of landing on a number less than 4, Albert? Less than 4. Or not less than 4, sorry. Not less than 4. So if it's not less than 4, it should be what numbers? What numbers on this wheel right here are not less than 4? 5, 6, 7, 8. How many numbers did you just say? 4 out of the, how many? 8, which is half the time. 1/2 the time. Okay, now we're going to do experimental probability. Out of 160 people that walk to work, about 100 out of 160 people surveyed at a company, 23 walk to work. So the experimental probability is 23 over 160, which you reduce. Look at the parentheses today. It says type an integer or decimal. So let's type a decimal for this. Somebody, calculator, take 23 divided by 160. What do we get? So it's 0.144 because it asks for a decimal. So if it's 0.144 and there's 4,100 workers at that company, about how many would walk to work? Jillian, what would you do with those numbers? Not divide them, multiply them. So take 0.144 times 4,100. What do you got? 590 what? 590.4. Now it says round to the nearest 10. What's the nearest 10 nearest 590.4? What would that be? The nearest 10, Lucy? Nearest to 590.4. The nearest 10. Would it be 590 or 600? 590. Exactly. 590 rounded to the nearest 10. All right, we'll skip one. The sample space for tossing 3 coins. Okay, you toss 3 coins. You got either a head or a tail when you toss the first one. Then the second one you toss is either a head or a tail. And the third one you toss is either a head or a tail, or a head or a tail, or a head or a tail, or a head or a tail. What I just drew is a tree diagram. So if you're ever asked for a tree diagram, that's what you draw. Now, what I'm going to write out now is called my sample space. My sample space is what the result is. You could get all 3 heads, or you could get 2 heads and a tails, or we go heads, tails, heads with the next one, or heads, tails, tails, or tails, heads, heads, or tails, heads, tails, or tails, tails, heads, or tails, tails, tails. Okay? This is my sample space. So when you're asked for a sample space, that's what you write. Now, what's the probability of tossing at least 2 heads? At least 2 heads. Are there at least 2 heads in this first one? Yep. Second one? Yep. Third one? Yep. Fourth one? No. Fifth one? Yep. Sixth one? No. Seventh? Eighth? So 4 out of the 8, which is half the time, you're going to have at least 2 heads. Half the time. All right. When it asks for a fraction, make sure you put it in fraction form. When it asks for a decimal, put it in decimal form. If there's 41% chance that it will rain tomorrow, what's the percent chance it won't rain tomorrow? Not 60. 41. 59. So then, instead of writing 59%, you write as a decimal 0.59. Read the directions. My first 2 classes didn't read directions very well. Please read the directions. All right, so this is all we're doing for tomorrow. So those of you who are behind on tests or quizzes or this or that or the other thing, you have time to catch up right now. I will hand out the worksheet now.